Hi, everyone. My name is Gwendolyn Faraday, and today I'm going to be presenting Intro to Blockchain for Python developers. I'm really excited. This is my first ever Python talk. So let me introduce myself really quick, and then I'll get into the itinerary for the talk today. So I'm a software developer at a SaaS startup company called Relevise. We build basically products in the marketing space using Python and Vue.js. I also create content online. You can find me anywhere if you look up Faraday Academy or just my name. I have a blog. I like to do live streams and that sort of thing. So join me if you're into that. And a few years ago, I'd say a little over 4 years ago now, I started a local community meetup group called Indianapolis Blockchain Developers because I live in Indianapolis. And I really wanted to create a space where basically all the other meetup groups in this area were all talking about investing or speculation, that sort of thing. And I wanted to create a space for technologists to talk about and learn about the technology behind blockchain. So I started this group a little over 4 years ago. Of course, with COVID, we kind of moved online. We have a Discord, so you're welcome to join us there. For the last maybe like 4 years, I have worked on several different blockchain projects. I've consulted for different blockchain companies and projects, worked on smart contracts and a few tangential technologies that I'll get into later. So that's my background in relation to this talk. I really come at this subject from the perspective of a software developer who's worked in these technologies and related technologies in the past. So hopefully I can share some of the things that I've learned with you today. So the objective today is that I hope that you can walk away understanding the fundamentals of blockchain and the terms related to the fundamentals. So when you're reading about blockchain or hearing about blockchain, you can really understand what's going on. And I'm also going to touch on the different types of roles or the different types of coding you might perform as a blockchain developer. I think when I first got into blockchain development, I thought it was one thing, and then it turned out there were a lot of different types of coding and things that I had to do that I wasn't expecting. So I want to share that with you. And then you're also going to be practicing building a blockchain locally and practicing with some technologies to interact with blockchains. The prerequisites, you probably saw this in the talk description already, but this is an introductory level talk for blockchain, but I am expecting that you already know at least Python basics because I probably won't be explaining what any of the Python code does, except how it relates to blockchain. So I'm not expecting that you know anything about blockchain. So I'm assuming you know little or not that much about blockchain, or you just really love blockchain and for some reason want to come to an introductory talk. So I'm going to start the first section. I'm going to go over how blockchain works. Before I dive into the code, I think it's important to understand the core concepts, the terms, and then to illustrate those, one of the best activities that I've found through the meetup group and through learning blockchain on my own and helping other people learn is building a blockchain in code. I think that was one of the things that that I found that really helped me, or that helps people learn about blockchain development. And then section 2, I'm going to talk about, like I said before, the types of development work in the blockchain space. And then I'm going to start interacting with a blockchain. And you can follow along. I have a link and some different code repos on GitHub. So we're going to talk a little bit about smart contracts. I will be using another language called Solidity, but if you know Python, you'll understand what's going on in Solidity. So I'm just going to do a brief overview of that as I talk about smart contracts and how they might be deployed and interact with them on the blockchain. Okay, so if you want to follow along, you can go to this link. It's a GitHub Gist link. I already shared it with Dave, so he should be sharing it with you. I'm not in Slack right now, so I'm assuming he's sharing it with you, but you can also go to this bit.ly link for the shortened URL, and that should pop up with this. So I have some links at the top. As we go along, I will be going over these links. This is the first one I'm going to start with in a minute. And then it goes through the steps as we start coding. I tried to break down the different steps for coding there. All right, so I'm going to get started talking about the blockchain. So one of my favorite things that I like to show, or that I thought it was funny, is how little most people know about the blockchain, but the term is kind of thrown out everywhere. It's a really hyped up technology, so everyone wants to go into it, but a lot of people don't know that much about it. So this is just a little cartoon that I thought was funny. The business person says we should build a blockchain. The tech guy knows that he doesn't know anything about blockchain, so he asks them this silly question about blockchain. And then I also got this funny tweet, or I thought it was funny, the other day. I believe he's a conference attendee or maybe a speaker, and he said my talk was potentially polarizing, intro to blockchain for Python developers. So I think, unfortunately, the term blockchain has become polarizing, I think because of all the scams and the hyped up projects that really don't have any meaningful technology behind them. But if you really take away all of the hype and all of the scams and all of the, speculation going on, there's really a lot of fascinating things going on in the blockchain space right now. So my favorite quote about this is by Andreas Antonopoulos. He is a thought leader in the blockchain space. He has a great YouTube channel, wrote a couple of good books that I'll have links to after. But he says, if you're content with the status quo, then you will think the blockchain does not add any value. So what value does the blockchain add? Actually, for different types of people, the blockchain will add value in different ways. So I'm going to go over a couple different rules real quick. So for businesses, I'm just giving my top three. Businesses are able to save money, eliminate middlemen, trust external entities. One case that was published a few years ago was Walmart using their own blockchain for their supply chain. And in some cases, or they use it for part of their supply chain, and it saved about 96%, I believe, on their costs. So for everyone, or for regular individuals, blockchain matters because it is censorship resistant, especially with everything going on in, Ukraine and Russia, and different governments and entities trying to control the flow of information. Blockchain is actually a force for censorship resistance, since it is a distributed network that anyone, so many people all over the world participate in. So it's nearly impossible to block. Also, there's no government or central authority that control it. One idea of blockchain is that you own your assets and your identity. It also allows for fast, direct peer-to-peer transactions, which actually save a lot of people time and money. Let's say in sending one type of currency to another type of currency, it has to convert and you have to send it over. Well, with blockchain, instead of going through a middleman and costing a lot of money, that can be done instantly for very, very cheap. So those are some of the reasons why blockchain matters. Now, for software developers, why does it matter for us? So blockchain is becoming ubiquitous. I know that's kind of a big term, but really more and more companies, almost every industry has adopted blockchain in some way. If you look at the Fortune 500 companies list, a lot of them, if not most of them now, are invested in blockchain technologies. I keep reading reports almost every week about new companies like Airbnb invest in blockchain technologies now. And there are just tons of jobs and opportunities to work for every different kind of company from the smallest startup companies to so many large enterprises that are using blockchain. So there's a lot of jobs and a lot of very interesting, innovative, cutting edge work to be done in the blockchain space. So why blockchain? Why is everyone so excited about it? Why are all these companies investing in it? So there are a couple basic problems that blockchain has solved. One of them is the idea of how can we trust unknown parties to be honest or to act in our best interest or the best interest of the network. If you've heard of something called the Byzantine generals problem, I'll just give you the quick overview. Basically, you have a couple generals, or maybe like 3 or 4 generals surrounding a city, and you're trying to attack in a coordinated fashion all at the same time. How can you trust that the other generals will attack with you? How can you coordinate it while you're sending out messengers? How do you know the message was received, and that, how do you verify that the message was received and that they received the correct message, and all of those issues? So actually, the blockchain is a fully distributed network. So in distributed networks, they would have the same problems about verifying consistency and consensus among parties. So the blockchain, through cryptography and through the algorithms that run in the network that we're going to talk about, has actually solved the issue in computer science called that Byzantine generals problem. And number 2, how can we know that we have achieved consensus in a distributed ecosystem where anyone can participate? So this is talking about the major blockchains like Ethereum and Bitcoin, where anybody can participate in the network. How can you achieve consensus? And that's because every single participant has a copy of the blockchain, and they can verify that that it's correct. And there are also algorithms or consensus algorithms to make sure that everyone agrees upon the current state of the blockchain. So let's talk about what a blockchain is. And this is one demo that we always show at our local blockchain group, and probably most people show in when they're showing an introductory talk to blockchain. And that is this Anders Brownsworth demo. So it's at the site andersbrownsworth.com, and it's also this link in that Git repo, or the Github Gist. Yeah. So as I go over concepts of the blockchain, we're just going to walk through some of these tabs at the top. So let's first define a blockchain. So Wikipedia says it's a growing list of records called blocks, and they're linked together using cryptography. So there are many different ways that people explain blockchain. They call it a reverse linked list, distributed append-only ledger. And I think all of these terms are helpful for understanding it, because it seems like kind of an abstract concept. So just a few characteristics of a blockchain is that it is append-only, that it's implemented in a distributed fashion. So everybody runs this software to participate in the blockchain, everybody all around the world. And it's append-only because once you basically add new data or a new block to the blockchain, it is hashed with the value of the previous block, meaning you can't change anything that happened in history. You can only add new data to the blockchain. And this is possible through cryptography. Cryptography means secret writing, which are obscured messages, but there are so many layers built on top of cryptography now. So I think it can be a little bit hard to understand what it's doing. So there are basically 2 major ways that it's used in blockchain. So public-private key pairs. If you see someone that says like, oh, send me Monero or send me Bitcoin or something like that. That is their public key, which can be hashed or whatever, but that's basically their public address. And you own, or you can verify ownership of that public address and send funds and transactions and whatever from that address if you own the private key for that address. And I'll talk about that in a second. But that's one way that blockchain uses cryptography. The other main way that it uses is through hashing functions. So a hashing function basically takes some kind of input, processes it in its algorithm, and then gives you the same length of an output every single time. Now that's used usually for verifying that data is unchanged because it's deterministic, meaning if you give it the same input, it's always going to give you the same output. So for example, this Anders Brownsworth demo, I can put an input here. So I'm just going to put fish. That's my cat's name, by the way. So that's always the first thing that comes to mind. But if I put fish here, you can see as I type, this hash down here completely changes. And it's not something you can predict. So if I change one letter, you can see it completely changed, right? It's not incrementing anything. There's no way you can try to figure out what it's going to be next. The only way to know what it's going to output is by actually putting in the input. And another characteristic is that from the output, you can never tell what the input is. So it's only one way. You can put input and it'll give you output, but you can never get from this output back to the input without already knowing what the input is. But this is really useful because if I put the same input, it's always going to give me the same output. So if I have a lot of data and I want to verify that it's unchanged, all I have to do is hash that data and then save that hash. And then later on, I can hash that data again. And if it's the exact same hash, I know that data hasn't changed at all. And that's a fundamental concept of the blockchain, and also how it proves that nothing in the history of the blockchain, none of the transactions that have been sent or anything have been tampered with, is through this type of cryptography. And yeah, here are some examples of cryptography that you've probably run into doing software development. So let's talk about the next concept, which is a block. So a block is just data. It's a data structure. So blockchain is fundamentally a data structure, right? And then blocks are also a data structure. They contain metadata. So usually you have something called a block header, which would have a timestamp. It would have like this field right here, which is the block number. It might have some other information about the block, depending on which blockchain it is. By the way, this talk, most of the information comes from the Bitcoin and Ethereum world, but it's applicable in the larger space of blockchain as well, even though different blockchains will implement things a little bit differently. So we have a block number, and then we have something called the nonce, which stands for a number only used once. And I'm going to get to that in a second. And then we have data, which is the real like body of the block where all the information is kept. Usually this will be in the form of transactions. So transactions sent from one blockchain address to another, or from one blockchain address to the blockchain itself, will be contained here, and a whole bunch of transactions will pile up in this data section of the blockchain. And then the block will be hashed basically. So there is a limit. There's always a limit to the amount of transactions in a block. Actually, there don't have to be any transactions at all, but generally, especially now with all the congestion on the network, a block will be filled up with transactions. And once it's filled up, then another block can be created. So each block is hashed with the value of the previous block. making it unchangeable. So I'm just going to add some data here. And you can see when I add data, the hash value changes. So I have to do something called mine the block. So I don't want to get too in detail about mining because I actually have a definition. Yeah, so it basically relates to something if you know proof of work. So I just want to give you a basic overview of what it is. Basically, you have to solve a computationally expensive puzzle. And the puzzle is that you have to guess this nonce number given some stipulations. So you're given a hash value. Let's say you're given a hash value of this block header, and you're given a difficulty level, which means how many zeros you have to have at the beginning of the hash. And then you have to solve for it using this nonce. So this is the nonce that solved this puzzle right now. And you can see if I get rid of fish, then the nonce no longer solves the puzzle because it's a different hash. So I have to mine this block again to solve for the nonce. That's basically how it works. It's the proof of work algorithm is going away. You probably hear in the news how environmentally unfriendly it is to have GPUs all over the world running and taking up so much electricity and everything. So different blockchains have come up with a lot of new, more friendly proofs. So Ethereum's moving to something called proof of stake. There's also proof of authority, proof of elapsed time. There's a whole bunch of different proofs that people have proposed and implemented, and a lot of different blockchains have their own proof of some sort. Each one has its pros and cons. So I'm not going to talk too much about that, but the major blockchains, Ethereum and Bitcoin, they do use this proof of work type, or they use the proof of work algorithm to validate blocks and also to reward people who participate in the network. So yeah, so if we look at a blockchain quickly, so this is what it means to have the hash value of the previous block. So you start off with block number 1, and you can see this previous value is all zeros. So this is block number 1 is always a special block. It's called the Genesis block. And there's basically no previous block. So you really don't have a hash value of the previous block, but you can hash the Genesis block. And then that hash value from the Genesis block will go into the next block. And you'll save that hash value in the next block. But this block number 2 is hashed with the hash value of block number 1. So that means you can't change the hash value of the previous block, or this hash value will break. And it will in turn break every single other block in the blockchain. So if I break this block and not break it, but change the information in the block, you can see Anders added this nice illustration turning it red. So it basically changes the hash value of this block, which means that the future blocks, they have the incorrect hash value because they've been hashed with the wrong value. So I would have to remine this. Of course, on a real blockchain, you don't remine things. If it's in a block and that block hash value is already stored in the next block, that means it's set in stone and it's not going to be changed. Kind of an aside, some blockchains have tried to implement methods of being able to change things. EOS and some other blockchains had some ideas about how to do that, especially for, is it called EDPR, the European law? Anyway, but in general, you can say that once it's stored in the blockchain, it's not going to change. It's stored in that immutable ledger forever. So one more important concept is transactions. So transactions are basically packets of information that are sent from one address to another. So at a basic level, they'll look something like this. So you have 2 and then an address will start with 0x and then something here, right? Some kind of string. In Ethereum, it's 42 characters. Different blockchains have different lengths. And then you'll have the from address, which is the same thing. It'll be another address. And then you'll have some kind of an amount or value that's being sent, something being transferred. And that is going to make up a transaction along with whatever metadata is associated with that transaction. Like timestamp in Ethereum, there's also a nonce for the number of the transaction that you've sent from that account, and a few other pieces of information. But that's basically what a transaction looks like. Now, when you send a transaction, this from account has to sign the transaction to make sure that it was really sent from that account. How it's signed is basically going back to cryptography with that public-private key pair. So it's called asymmetric cryptography. And basically, if you encrypt something with the private key, it can only be decrypted with the public key. So if I was to encrypt this transaction here, just this one object with the private key, then I can put my public key out there so every single person can verify that I was the one, I'm the owner of this account and I was the one to encrypt this transaction. So that's basically how it can work for verifying that I was the one who really sent this transaction. So the blockchain uses cryptography in that way as well. And then, so for addresses, we had the to and the from address, and you can see kind of a screenshot. These aren't real addresses. This is from a dummy blockchain, but this is a public and private key pair. And there are a couple different types of addresses. So you have externally owned addresses, and these are addresses that a person or human owns. So you have your private key, you can have funds attached to this address, you can send transactions from this address, and all of those things. So in the other type of address is a contract address. So this is where you've heard of things like smart contracts, or if you know applications, some gaming applications or CryptoKitties or something. Those are contracts that live on the blockchain. And basically when you deploy some code or contract to the blockchain, it lives at a certain address on the blockchain, and you can always reference it with that address. So there won't be a public-private key pair, but there will be an address where you can access that. And basically how you put that on the blockchain, you send the transaction without anything in the to field. So there's no address you're sending it to, and then the blockchain, or at least for Ethereum, it knows that you're trying to deploy some kind of code in the data of this contract, and it will handle doing that. Okay. And then lastly, I did mention nodes. So I just want to say that nodes are just computers that are running the software. So whatever client software they have for that particular blockchain, be it the Bitcoin, or they could be running Ethereum client software like Geth or Faraday or something, or Hyperledger, or whatever kind of software they're running, they become a node for that blockchain. So I want to get into a demo of building the blockchain now, which is actually at this GitHub repo, if you want to check it out. And it has, real quick, does anyone have any questions so far? I can't see anybody. So it's kind of, yeah, I'm just talking to my camera, so I don't know.
Robert had a question
about
wallet addresses. Can two people have the same wallet address? How does that work?
No, every address has to be unique, because if you send money to in address, the only thing you have is that address. So it's not like a bank account where you have, your account number and your routing number. In the blockchain, you don't need both of those things to send money. You just need the public address. And the public address has to be unique because that's how anybody can send you money on the blockchain. And also because of the private key is used to generate the public key. So there's really no way for someone else to generate that unique address unless there's something terribly wrong with the cryptography. Does that make sense?
Okay, I think so. So the blockchain, the address, and the private key, those are three different things, right?
Yes.
Okay.
So the blockchain,
So
is
the public key is published on the blockchain at the end and is associated with particular hash. So what I'm trying to ask is, what does make like the one account or one wallet address a wallet address?
Yeah, so wallets can have multiple accounts in them, and each account will have a different public key to send money to. Basically. Okay.
Sounds good. Okay, just continue. Thanks.
Okay, thanks. Yeah, so let's go over to GitHub. So if you look at this repo, GitHub, my GitHub is GwenF, so you can find all of the blockchain repos that I pushed recently. And this one's called Build a Blockchain. And you can see I have the different steps here. So step 0, step 1, step 2, step 3, and we can just step through those different steps. Of course, this won't be a comprehensive build every single feature that exists on blockchain, but I think it is a good way to help understand what blockchain is and go from there. So I have this repo locally on my computer. This is on branch 0, and I'm going to go through. I'm going to go through these steps to basically create blocks and transactions. And then you can see, I create blocks and transactions, and then in the next branch, I'm going to chain the blocks together, and then I'm going to add cryptography. And just real quick, if you look at this, I also added some additional steps that I don't think will, oh wait, is it here? Yeah, it's here. So I don't think we'll get to today, but you can always add those to the blockchain or to your own blockchain if you want to continue building this prototype for learning purposes. All right, so yeah, let me start off with step 1, create a basic block. So I have my block file here, and 1 second. Yeah. So I'm just going to create a class, and then block. And then 1 second, actually. Okay. I had some different code. So yeah, I'm going to create under the init function and self. Okay. I think I'm nervous now. So I'm going to just copy this actually. I think it will be easier and then I can explain it. So I can, so blocks always have a sequence or a number, a block number. So I start off with 0, which is the Genesis block. I'll have code to actually update this later. And then for now, I'm just going to store a list of transactions on this block. And then I'm going to do add a method to basically add transaction to the block. And that's going to take self, and I'm going to pass in a transaction. In the blockchain world, you can see TX, or transaction is often abbreviated as TX. And then I'm going to just copy this. And basically it adds a transaction to the blockchain's ledger. I just append that. Yeah, it's just standard Python. So by the way, I have black auto formatting, so that's why the code might change a little bit after I save. And then the last thing I'm going to add here is just for prettiness, add a string representation. So since it's a list of transactions, I'm going to print out the string representation of each transaction, join those on new line characters just to make it print out a little bit easier since I'm going to be interacting with this in the terminal. Okay, so that's basically a blockchain or a block, the block class I'm going to make. And then I'm going to go through transaction. And this will be a transaction class. And basic. And then I'm going to have another init function. And I'm going to copy this. So basically what these are, and I don't have address types here, but these will actually be addresses. So to and from. And the reason why I'm using the underscore is just for Python, because from is a reserved word, and to, I don't have to use the underscore, but just to match from, that's what I did. And then I'm also passing in the amount for the transaction. So some very basic information for the transaction. And then I'm also going to do a repr function for this as well to print it out nicely, just the from and to addresses with some formatting, and then the amount. Okay, so those are the only two classes that I need. I do need a couple other things, but I do need to be able to get addresses. So the from and to addresses. And for that, I'm just going to write a couple helper functions really quick. And I need a couple imports. So I'm going to take these. So I need to be able to generate random numbers. And then these are just nice things that Python gives me. If you haven't seen those before, then let me just print them out. They're just strings. So basically, if I do digits, I get a string of all 10 digits. And then if I do ASCII letters, I get a string of all of the lowercase and uppercase letters of the alphabet. So that's just a feature of how nice Python is. All right, so, and then transaction is of course the class that I just made. So I'm going to do def, and then let's see, generate an address to create an address. And I don't need to take anything, it's going to return a string. And I'm going to copy my block string here. So I'm going to generate an address, and the format will be kind of like Bitcoin's addresses. You know, every blockchain generates their addresses a little bit differently. But here's a link if you want to know more about Bitcoin addresses. I think maybe I can post them in the chat. Yeah. Okay, So this is a base 58 address. And you can see in the wiki here, there's a lot more information about why they use that particular system. But there are some characteristics of these addresses. And so I'm just going to copy this. And there are characters that are omitted from addresses that they don't use. And I have kind of a pretty font in the text editor, but if you just had like a standard web font or something, you would not be able to tell that this is a 0 and this is a capital O, or that capital I and L. And coming from Python, you probably already know those things. Python has a lot of good recommendations about that kind of thing. But yeah, that's why these are omitted from addresses, so they don't cause confusion in sending to the wrong addresses and stuff. And then here, all I'm doing is creating a list. Basically, I'm looping through the combined string of all upper and lowercase letters and digits, and then I'm omitting these characters that don't belong in addresses. So I'm creating a list of all the characters that can make up addresses, and then I can actually generate an address. So I can do address, and I'm going to make that a list right now. Oh, this one on the line. Okay. And then I'm going to say so addresses, at least in the addresses that we're creating, can be a random length from 26 to 35. So we're just using the random package from Python. So random.random, we're choosing a random number, and we're going to loop through this. And then, however the length of our addresses, we are appending onto this list. And then the only thing I need to do now is just join. So I'm going to use this string method join, and join all of the characters in this list, and that's going to return an address. So I can actually, I'll just print this out. Generate address. I don't need to pass anything in because it will just generate an address on its own. And I can do Python, and then helpers.py. And it generated this random string for an address. If I run it again, it's different every time. It's also a different length every time based off of whatever random length. So that's based off of Bitcoin addresses. It's just what I'm going to use in this example. And then I'm also going to make one more helper function, which is to generate a transaction. So generate transaction, and this will actually return the transaction. So let me copy this. Okay, so I have a to address. I'm generating a random to address, a random from address, because I have no concept of actual accounts yet on this blockchain. So I'm just creating addresses just for the purpose of transactions. And then I'm going to also do that with amount. So choose a random amount, and then create a transaction with those addresses and a random amount. All right. So that's all I need for helpers. And then in main.py, I have kind of the boilerplate here. And yeah, basically I'm going to create a block, populate it with transactions, and then print it out just for step one. Okay, so for this, I'm going to import block. Oh yeah. I need to do from block, and then from transaction import. Or no, I'm actually creating the transaction in the helpers file. Okay, so helpers import, let's say, generate transaction. And now I can create that here. So I'm just going to copy this. And I'm creating a new block from the block class, and then just this number that I chose, 5. So I'm going to add 5 transactions to the block using that method on block. So add transaction, generate transaction to pass in a new transaction. And then I'm going to print out the block here. So I am going to, I think I had some code I need to remove. Oh, I was printing, but I guess I already removed it. Okay. So let me try to run that. So Python Pi. Let's see, no module found. Okay. All right, so I have an error. From block import block. Import self, what? Oh, this accidentally got imported. Okay. It was auto imports when I mistyped something. Okay, well, it didn't happen in the class. All right, let's try again. There we go. So I might have to zoom out a little. And that's basically a transaction. So, you know, transaction, this is a string representation of the transaction. And then in a block, it's just looping through those when I print it out. So when I print out a block, it's printing out all 5 transactions consecutively. So now if you go from branch 0 on GitHub, if you go from branch 0, where we started, and go to branch 1, you'll see the code should be exactly like what I have now. And that's a starter for branch 1 or step 1, or it's the finished code for step 1, but it's a starter for step 2. Okay, so for step 2, I'm going to check out. Okay, I'm going to copy paste a new list here. So for step 2, I'm going to be chaining the blocks together or making blocks into a blockchain. And I'm going to update my doc strings here. All right. And there's a couple things I need to change. First, in block. So if I'm going to get the blocks in order, I need a block number. I know in Python, when I make a list, it's going to be ordered anyway, but just to make this more like a blockchain, I'm going to add a number onto this class here. So to do that, I'm actually just going to use Python's iter tools. So import iter tools. And then here, I'm going to add that number. And I renamed this for some reason, but this is the same thing that a sequence was. So I'm going to call the next function. And this will iterate. So every new block that I create now, it will increment. So I'll start at block 0, and then the next block that I create will be block 1, and so on. So that's all that I have to do for blocks. I think that's all that I have to do for helpers. And yeah, that's it. So now I just need to update my main function. And then I'm going to actually add a new variable here. So, and let's call this block size. So the block size is sometimes a matter of contention on blockchains, but it's a set size of how much can fill up the blockchain. In my case, I'm just going to count transactions and say that the blockchain can, or each block can only have 5 transactions in it. So yeah, let me add a comment. And then I'm going to say blocks. So blocks or blockchain or whatever, and have that as a list. And then I'm not going to need that, or actually I do need that, but inside of the loop. So I'm going to create a new block. I basically chose just any number. I want to create 5 blocks, and I need to add transactions into each block. But I don't want to add 1 transaction. I want to add up to the block size. So I'm going to do for underscore in range. And then this will be up to the block size. And this will be block.add transaction. So that would add 5 transactions. And then instead of printing, I'm going to append this. So blocks.append block. So I'm appending it to my list of all the blocks. And then I'm just going to copy this for loop here. And this is just for printing purposes, to print out the block number and then the list of transactions with a delimiter, some space in between. Okay, so I'm going to run that. There we go. All right, and this prints out the different blocks. So I have block 0, block 1, block 2, and those each have transactions in them. Now, right now, there's no way to validate that the data is correct, or integrity is very important in the blockchain. And without cryptography, there's no way to verify that this transaction information hasn't been changed, transactions haven't been removed or added or updated. So to do that, we really have to hash the blocks and then store the hash value of each block on the next block. So I'm going to do that real quick. And this is in, if you go into step 2, we should be at this point in the code right now anyway. So I'm going to, oh yeah, 1 second. Okay, so we're going to enforce integrity in this step. So to do that, let me copy this. And yeah, so actually not much changes in this file, although something will change. Why is this being imported? Okay, so in block and in helpers, so let's go with helpers. There's a couple new helpers that I'm going to add, And to start off with, I'm going to add a hashing function. Now, this is SHA-256. Ethereum uses, I think it's called Ganache 256, and different libraries use different hashing functions, but it will all be the same idea behind the hashing. So this is just the one from hashlib in the Python library. And I'm going to, oh yeah, I'm going to have to import block. So from block, import block. And then I need to define a couple more functions here. So the first one is I'm going to have to hash a block. So there's a couple different methods of hashing data. Of type block. And we want to hash an entire, we want to hash an entire block. So we could feed in different parts of information, hash each part, and then hash them together, or hash one part and then hash the next part with that one part. And if you read the book, actually Blockchain Basics, there's a really good section about all the different ways that you can hash information together. Basically, a hashing function takes one piece, can only take one piece of information. So what I'm going to do here is just stringify, or use a string representation of a block and use that. Sorry, one second. And use that as the information to feed into the hashing function. Sorry, I have allergies and I guess I'm losing my voice. Okay, I'm gonna have to take a break in a minute. But let me just finish this section. So I'm going to copy this, and then for lack of a better name, I'm just going to do block string, or the string representation of the block. And then just pass in whatever block here, and then I can return the hashed values. So SHA-256, I can pass in that block string. And now just for the algorithm, it's going to require a byte string. So it's going to give me an error. So I'm just going to use the encode method, and that will give me the byte string. And then I am going to use another method that comes with these hashing algorithms, which is hex digest. That will give me a hex string. Yeah, and let me, I guess I'll test this in a minute because I need to pass in a block. I guess I could pass in any value for a block, actually. So let me test this function. And hatch. Okay. So oh yeah, I forgot. I ran that other one. Oh, and it's not printing out anything. Anyway, I have to run the actual helpers file and print it out from here. So if I print out that, I can do Python helpers.py, and that is the hashed value of the word fish. Of course, I can make this any length, and the hash value is going to come out the same length. Yeah, it's just a completely different hash value. Okay, so my hashing function works. And now I am going to create a helper function to create a block. And that's because now on blocks, I do need to add a previous block hash. So actually, I'm going to have to add that in the init function here. So let me add just this one line to here, the previous block hash, and I'm going to have to pass that in when I create a new block. Pass in a previous block hash, and then it gets stored on this block. Of course, for the Genesis block, I'll just be passing in an empty string. Okay, so I'm going to define a new function, and that will be create block. And here I'm going to actually have to take a list of blocks, or the list of blocks. So let me go. And this will return a block. And now I'm going to copy this try except. So I'm going to initialize a new empty block using this instead of the block class directly. And I am going to, basically, the easiest way I found to do this is to pass in the whole list of blocks, check and see, get the last block in the list. Of course, if there is no block in the list at all, that means it's the Genesis block. But because of Python, it's going to give me an index error. So if I have an index error, I know there aren't any blocks yet, and I can just set the previous block hash to an empty string because I know it's the Genesis block. And then I can create a new block from here and say new block, and let's say previous block hash. Yeah, leave it like that. And then I can just return that block. All right. So I'm returning the block from the function here. So now if I go to main.py, I don't need to create the block directly. So I don't need to import this. Instead, I can do create block, and then here. So I have to create block. Of course, now that create block function is expecting the list of blocks. So I do have to pass in the whole list of blocks. And yeah, that should create blocks with the hash. The only thing I'm going to do is update the print so I can print out the previous block hash, I guess. All right. And now I'll do Python main.py, and that does print out all of the blocks with their hashes. So hash of every previous block, which is hashed with the previous block hash. The only one that doesn't have a hash is the Genesis block, this first one. Yeah. So like I said, this was probably the most helpful exercise for me when I was learning, and when people I know have been learning, and we just keep trying to add new things and features to the blockchain to really try to understand the implementation or how it could be implemented. Of course, Python is a really great language for prototyping, although I don't think any, no major blockchains are written in Python itself, but it's a good language for prototyping blockchains. So if you want to do more steps, like I said, I wrote out some steps that you might want to add to this blockchain as you're learning. Of course, you can fork the code that I wrote and use it for any reason that you want. Okay, it's 11:05. Are there any questions now? Otherwise, I'm going to take a quick break and come back.
Jessica had one question. She said her Wi-Fi was cutting out, so she may be a bit behind the stream. Could you explain a little bit what the Genesis is? It started at 0, but then became an incrementing number. So is the genesis the starting block for the chain?
Yeah, the genesis is always the very first block of the blockchain. Like the Bitcoin Genesis block, I think it came out in what, January 2009 or something. And the different thing about the Genesis block is that it can be initialized with some special code, like there might be a message, or it might, you might automatically send funds to somebody, just so somebody on the network has funds to start with, or you can write special code to do whatever you want. And the big difference is that there will be no previous block hash because it's the very first block. So every subsequent block is going to be hashed with the previous block, but there is none for the Genesis block. Yeah, so I guess it's just a term meaning the very first block in the blockchain. Hi, everyone. It's been about 5 minutes. So I'm going to go ahead and start back. For this section, I want to show a library called Web3 Pi. So it's great to kind of test and try to build your own blockchain and learn through that. But how you'll actually be developing with blockchain or creating your own applications that interact with the blockchain is through tools like Web3 Pi. So my background of developing on blockchain is mostly with JavaScript-based tools like Truffle, Ethers.js, Web3.js. And more recently, I found that Python actually has this really great community and suite of tools to work with blockchains like Web3 Pi and Brownie and a lot of related tools. So that's what I'm going to be going over now. If you look in the gist that we shared at the beginning, there are a couple links here. So I'm going to be covering MetaMask, which is just a really easy browser plugin. And then also Ganache. If you're on a Mac, it's really easy to install Ganache with brew cask. Otherwise, it's also easy from their website. They give you different download options for each operating system. And let's see, yeah. And the other library is Web3.Pi on read the docs that I'm going to be looking at. So that's right here. Sorry, some of the things I try to keep dark mode on, but Ganache and some of the websites won't have dark mode. So sorry about that. All right. If you have any questions on the way, you can just post them or stop me as I go. I do have a repo that hasn't been filled in with anything yet. The only things I've done so far are create a virtual environment. So I just use the basic Python VN for that. And then I did source VN bin activate. So I'm in my virtual environment right now. And then I just generated this git ignore, and I have an empty main.py file, and I'm using Poetry as my package manager. You can use whatever you want. I just always use Poetry by default. So to install things, I'm going to use Poetry. All right. So I have the docs open, and I'm going to put this here. And I'm going to follow the steps that I laid out here, or tried to. So I have web3.py here. And I have my setup steps. So install the Ganache Gui. That's the program that I just mentioned. So if you go to Ganache, you have to type in Ganache blockchain or something, or it shows you a bunch of chocolate. Okay, those are both the same site. So here's yeah, this is the Ganache site. Basically what Ganache is a JavaScript implementation of the blockchain. So of the Ethereum blockchain. And it gives you a lot of tools to test and build blockchain solutions locally. Some people think it's just a test environment for learning, but it's actually used as a local environment, kind of like, I don't know if you use AWS, but you know, they have the local implementation of DynamoDB and all of those things that you can run locally while you're building locally. Well, Truffle, it's similar. Truffle provides a similar solution that actually gives you a lot of options for developing as your local environment too. So that's Truffle. I already have that installed and running over here. Every time you exit out of it, it will reset this whole account. I guess I can just show you a couple of the options here. So it gives you 10 accounts out of the box, which if you've ever tried to develop with blockchains using test nets, you know, you have to go to a website called Faucet, where you try to get some test ether, which may or may not be working. And sometimes you have to do a couple steps to get the test ether, and it never gives you 100 test ether. So this is a really easy way to start developing without having to worry about going and getting ether, because you have 10 accounts and you can add more, and they're all pre-filled with 100 ether, which is the coin on Ethereum. So I have these 10 accounts with 10 addresses. It also gives me access to the private key here. Of course, really, I wouldn't be showing my private key, but here it doesn't matter since these are just test things that were generated. If you're wondering what this mnemonic phrase is, you'll see this in different wallets on the blockchain. Like if you use the MetaMask browser plugin, this is basically a phrase that is used to generate all of these accounts. And they will generate all of these accounts in order. So if I don't know any of my account addresses, but I have the mnemonic phrase, I can generate this account and then this account and then this account over and over again. So if this is connected to a real wallet, then I need to keep this mnemonic phrase very secure. It also gives me information at the top. So the current block number. So it mined an empty block here. Yeah, mined an empty block. And then I basically have it set up to auto mine, which I think is the default for Ganache, meaning every transaction it's just going to auto mine. It's not going to wait, because if you on Ethereum, every 12 seconds it will mine a block. So however many transactions you can fit, you know, every 12 seconds a new block will be mined. That will be will have transactions. On other blockchains, it might be less than a second, up to 10 minutes or so. So yeah, but now for this test blockchain, I could update. There's a lot of mining options that I can pick, but I'm just doing it for testing purposes to mine everything right away. Okay, so it shows me which, it's hard to see because it won't let me zoom in, unfortunately, on this. I don't know if there's any other way to zoom. Yeah, it's weird because this is actually in, I think it's in something called like Electron, because I can inspect stuff and it does give me this JavaScript console, and I can zoom in over here for some reason, but I can't zoom in on the main thing. Anyway, I do have my server where that's running on port 7545 is the default. The network ID for where this blockchain is running if I had more nodes. And then I have, yeah, which hard fork, or I can use a copy. Basically, locally, I could use a copy of the main net, like the production blockchain, or I can use different, I guess, different hard forks or different blockchains, but I'm just going to leave the default. And then I do have gas. So I don't think I talked about gas, but to make transactions on the blockchain, if I'm ever going to store anything on the blockchain, because things can't be updated on the blockchain. So I have to always store new information, whether it's new or just trying to update something that's already there. So if I ever store anything on the blockchain, then including any kind of transaction, I'll have to pay a transaction fee, which is called gas. And that fee fluctuates because there's no central authority that's saying, oh, the fee has to be this much. It's based off of basically how much, how much the market is paying at the time. So the gas price can go up if there's a lot of congestion. You basically have to offer, I want to pay this much for the transaction fee. And then the miner, whoever mined that block, can optionally include your transaction. So if you're paying a very low gas price and everyone's paying more than you, you might not get your transaction included in the block. So you kind of have to pay around the medium price, or around, the average price that's getting included in blocks, which goes up and down, if that makes sense. But I'm not going to worry about gas prices now. This is going to show a history of transactions, contracts. I can see logs, which I don't have anything here yet. Yeah, so that's basically how it works. And now I'm going to be using that blockchain to interact from Web3 Pi. So I'm going to, I already have it installed here. I think I installed it. Yeah, so if you look here, I have installed dependencies. So poetry add Web3 Pi. This one is a Solidity compiler. This Pi solcx, and then python.env, which I'm not sure if I'm going to be using, but it's there. Okay, so I'm going to do just poetry install, make sure I have everything installed. Okay, everything's already installed. And now I can start writing. So I'm going to say Web3 import Web3. And then I need to connect. I'm going to be interacting with this Ganache blockchain. So I need to get the address of where that's running, which is, I'm going to use the HTTP server. So that's on port 7545. And I can change the port if I want, but that's the default. So I'm going to say that's the URL of my blockchain. And then Web3.Pi. Basically, in the overview section of their docs, if you scroll down, you can see their API. It has a bunch of helper functions for stuff you commonly need when you're developing for blockchain, like is it an address, or verifying if it's an address, converting from Ether to gas or whatever to we. Hashing, and then they have the Web3.eth API. You can send transactions with it, and then they have contracts and some other functionality. So we'll be using the this Web3.eth API, and we'll also be using their contract API. Okay, so I have the URL, and now I'm gonna create an instance of Web3. So I'm gonna do Web3 and call that. So Web3, and then I have these helper methods. So HTTP provider, I think providers, here we go. So this goes over the different kinds of providers that you can use, basically which blockchain are you trying to connect to? And you can connect via HTTP or WebSockets, or if you have a local actual node running, you can connect to that. It does have a built-in one. I was trying to find it. yeah, I'm not sure. There is one built in. So this Web3 Python library will give you a provider, but it doesn't have all of the features. Yeah, it's basically just a simplified version of a mock blockchain. So I think it's better. It's also very easy to just connect to connect to a Ganache blockchain. So, okay, HTTP provider, and then I have to pass in the URL. And then that should be everything I need to connect is connected. So let me check my connection status. I'm just gonna print that out. And then in the terminal, do Python main.py, and it prints out true. So it did successfully connect to my blockchain. There shouldn't be any issues with the local blockchain. Sometimes you run into something trying to connect to a node, which is a little more difficult, or using private keys or something. But yeah, this should be pretty straightforward. And now I can basically send transactions. So I'm going to just show it send transactions, and then I'm going to actually interact with contracts and deploy contracts. Okay, so because I'm using a local blockchain, I automatically have access to my accounts. So let me actually go and I'm gonna, let me import Web3, do all this in the REPL. That way I can just rerun stuff easily. My URL. And okay, so now I have W3, I'm connected, and I can see, I can use the Ethereum API to get my accounts that I have set up. So I can see all of my accounts here. I could get the balances for those accounts or interact with them on my local accounts. So that's basically what I'm going to do here for sending and receiving transactions. So I'm going to say accounts 0 and send from my first account, which is this account, and just send Ether to this account. So I'm going to create a transaction. So let me create a dictionary, and then I have a to address. So actually, let me do from. So from that 0th account, and then I'm going to do 2, and then W3 dot accounts. And this one will be to the account at index 1. And remember, these are just addresses. So I don't know what it's showing there. Okay. Yeah, but that's just a list of all the addresses for all 10 of those accounts. So I can create a transaction, let's see, from, to, and then I do need to send some kind of value here. So let me put this on the next line so it's easier to see. Auto formatting will hopefully fix it. Okay, so I need to send some kind of value. Now, what's interesting about value in blockchain, so if you know, probably any currency, so I live in the US and we have our smallest bill is the $1 bill, but we can break that up even further. So we can break it up into quarters, which is 0.25, dimes 0.1, nickels 0.05, and pennies 0.01. And you really can't break up currency any further than that. But in blockchain, you can. So Ethereum and most blockchains make it so you can break up. Let me look for two. Okay, so when you hear about Ethereum or Bitcoin, you hear about usually whole numbers like 1 Bitcoin, or maybe a partial like 0.5 Bitcoin or something. But actually the smallest amount of these currencies is this very, very tiny number. So you can see charts that show the names, like there's Gui and Gui and all these other things, all the way up to 1 Ether. But the smallest amount, which is this Gui, it takes this many Gui. I can't even pronounce this number. I can't remember what it is, but it takes this many Gui, millions and millions or whatever, to make up 1 Ether. So it would be very annoying and mistake-ridden to actually put this in our code. So we have utility functions from these libraries that will convert between Ether and Gui. So I'm just going to do W3 dot to Gui, and then I'm going to say 10, because for gas or for sending transactions, I do have to send the value in Gui, not in Ether. So that's why I'm using this utility function. And then that's right. Okay, so yeah, so that's my transaction that I'm going to send. And then I need to send the transaction. So W3 dot send transaction and pass in the transaction. And that's basically the API. No matter what blockchain I'm using, I'll use the same method for sending transactions. The only difference is if I was using an actual live blockchain, I would need a private key to sign the transactions. But since I'm doing this locally and my private key is not private, so W3 or Web3 Pi isn't making me, actually sign the transaction. But let me try running this file again. So Python Pi. Okay, all it says is true because it's printing out this, but I can actually look in Ganache and explore. You can see that a new block was created because I sent a transaction. It's automatically mining just one transaction per block, basically. And then gas used, it shows how much gas I spent from that account to run this transaction. And you can see I do have 90 Ether now, and now I have 110 because I sent 10 to that account. And you can see the transaction log here, the sender's address, the to address, and the gas information, block information, and then how much Ethereum I used. And so this is a convenient local block explorer. There are also websites if you're using an actual like testnet or the main net or the main networks, then you can use a website that will act and basically give you this information and more. So let me go back to accounts. And so there's a lot more you can do in the API with sending and receiving transactions, but those are the basics. So when you're working in blockchain, actually I missed this part. Yeah, so when you're working in blockchain, if a company is having you maybe build a wallet to interact with the blockchain or do something like that, you'll be using a tool like Web3 Pi and making functions that, you'll store someone or have them enter their account or connect their account, and then you'll be able to interact with the blockchain in that way. So actually a lot of the work, like if you get hired as a blockchain developer, a lot of the work is not actually on the blockchain. I would say definitely more than 50% of the work, maybe like 75 or 80% of the work that I've done in blockchain was not on an actual blockchain. So the different types of work, I kind of broke these into 5 sections. You have people who work on the core of the blockchain, which I haven't done, but they'll work in like C++ or Rust or Golang, and they'll work on the actual implementation of the blockchain protocol and the nodes, and also the node client software and stuff like that. And then you have smart contract developers. So a lot of times these will be languages that are specifically built to use on a blockchain, and they'll be kind of, the syntax will kind of copy usually a popular language. Like Solidity is kind of like Java or maybe like JavaScript. So if you know one of those languages, it's probably easy to jump into Solidity. I'd say it's pretty similar to a typed version of JavaScript, in my opinion. And then Viper is very much like Python. It looks like Python when you use it. It's a security-focused language for Ethereum. Yeah, so that's smart contract development, and that's actually putting smart contracts on the blockchain. I'm going to show a couple in a second. So that's actually the code that runs on the blockchain. But even if you're creating smart contracts, a lot of the coding that you'll do for those smart contracts are actually in the deployments. So when you're building smart contracts, you need to have deployment scripts and a testing environment, and you need code that will compile the smart contracts and keep compiling them as you make changes, and you have to deploy them to different networks. You'll have a local and some kind of staging, and you'll deploy to different test nets, and then you'll deploy to the main net. So you need to have your, I guess, infrastructure, your CI/CD as code, however you implement that. And so you also use Web3 Pi and Brownie for that. And then you have integrations and tools. So this is a lot of the work in the blockchain space. I think the first company that I worked with in blockchain, like actual company, a lot of the work was that they were building a browser plugin, and then they needed a UI, and they needed all these other things to actually be able to interact. And the amount of smart contracts that we had to develop was a lot less compared to the code for the browser plugin and for other features and for the deployments and everything. And then there's also the fact that, you put a lot of your logic, or you'll put certain types of logic on the blockchain, but there are a lot of things that you really don't want to put on the blockchain. Like if you're generating random numbers, or you need to store large amounts of information, that would be prohibitively costly to do on the blockchain. Because since everything gets stored forever, it's very, very costly for each piece of data that you store, especially compared to cloud services. It's like orders of magnitude more costly than just storing on a cloud service. So a lot of people, or most projects, I would say, have some kind of off-chain compute. They're usually called oracles, and they'll have or off-chain storage. You can do those two things in decentralized or centralized ways. A lot of places will use centralized options. So they'll use they'll have some of their code on AWS, and then they'll deploy some smart contracts to the blockchain as well. One popular tool has a lot of their logic on the blockchain, but then off-chain, it's a cat. It's a crypto kitties. So they basically, it's a cat service, I guess. I don't know how to describe it, but yeah, just like the internet, cats take up a lot of bandwidth on the blockchain. But you collect and you breed cats, and you can collect things and do things with cats, basically. But they have their special proprietary DNA. At least last time I looked, they had that off chain so that nobody could see it, because everything is visible on the blockchain. And then they had all of their contracts for how their breeding and cat adoptions and all that stuff works on chain. Yeah, and then integrations with web and mobile apps. A lot of times you'll have to build some kind of front end for users to actually interface with the blockchain code that you wrote. And in the browser, they do have Web3 libraries that will let you interact directly from your front end. Sometimes you don't want to do that, and you'll have a back end, you know, the regular front end and back end, and then your back end will call the blockchain. And then, like I mentioned before, Python is always great for prototyping just about anything. Yeah, yes?
Jessica had a question. Would it be possible to explain in a little more detail what mining involves? Thanks in advance.
Yeah, so mining is a little bit complicated to explain. Let me go back to here. So mining, basically, in order to make the blockchain secure, or this was the security solution of original blockchains like Bitcoin and Ethereum. So they have these puzzles that are computationally expensive and that you can't guess without brute force. So these puzzles are cryptographic puzzles that come from two things, from hashing something like a block header, and then a difficulty level. And that's how many zeros you have to add on to the beginning of a hash. So like here, I could say this is the hash, and then I need you to find a value for the nonce. Well, it's easier here, actually. I need you to find a value for the nonce that has 4 leading zeros after I hash this header. And so you can see that would mean it has a difficulty of 4. So you can see this is the nonce that solved that puzzle, but you'll have, you know, people sending billions or billions of guesses every second, or whatever, however amount it is, trying to guess this value. And it could be, you know, it could be a lot longer, but you have no idea what it is. Yeah, until someone actually solves the puzzle. So the reason why they do that, I guess, is because so there's something called a 51% attack in blockchains. And that's if you own 51% of the nodes, you can say something is valid that's not valid. So you can just verify things on your own that aren't really valid transactions, let's say, if you own most of the network. Because whatever chain or whatever copy of the blockchain or the ledger that 51% of the network, at least 51% of the network is using, that is what is considered valid on the whole blockchain. So if you own 51% of the blockchain, then you could say that it's not valid. Yeah, I guess it's kind of hard to explain, but basically making a computationally expensive task to have to solve means that nobody can just add blocks to the blockchain, that it would, to take over the network, that it would take more computing power than exists in the world right now, I think. Yeah, I don't know if that's a good explanation. I have a couple books that I can share with you that explain more in depth, how mining works. I have a list of my favorites. So yeah, I don't know if that helped.
Great, thank you.
Okay, thanks. Yeah, let me see. Maybe we can talk about that after too. Okay, yeah, I just wanted to touch on public versus private chains. So I've been talking about public chains, or anyone can participate in the network, but there are also private chains. So when you see a lot of business success stories in blockchain, like Walmart supply chain, those are examples of private chains, and they control who can participate or view data in the network. A lot of private chains will only allow certain parties, verified parties, to participate in the network. And that, of course, makes them more secure, as far as not needing a lot of different nodes to make them secure. But it also makes them more centralized. So yeah, there's different ways of thinking about that. I don't really want to go into that, but the only private chain that I've ever worked with is Hyperledger. So there's Hyperledger Fabric and Indy and a whole bunch of Hyperledger projects that are owned by the Linux Foundation. So those are really good blockchains if you want to learn about how private blockchains work, and you can spin up your own kind of network of nodes and play around with those. Yeah, so back to Web3. So we talked about transactions, and now I want to talk about compiling. So I'm just going to compile locally. So I need a couple tools to be able to do this, and I also need contracts to be able to compile. So I pre-wrote these contracts. I'm just going to paste them here. So I have a couple contracts that I've made in the past that I can just play around with. And the most basic one is this calculator. It's not really a calculator, but it shows the basic main functionality of a blockchain contract. So I'm actually going to put this into a web editor so I can show this real quick. And the web editor that I'm going to use is this thing called Remix. So if you go to the site, please make sure you go to the correct site, because there are apparently a lot of fake sites that try to have a similar name, like remix.ethereum. You need to go to remix.ethereum.org. I think they even buy sites like .com or .something else. But yeah, that's the official website. So you'll see this homepage where you can, I guess it gives you different information, and you can use different plugins. So you can program in different languages in this IDE. So I'm just going to use Solidity here. And on the sidebar, it gives me a compiler here that I'm going to use in a second, a place where I can deploy the contracts and set gas and everything like that. And then a file explorer with contracts. And so I have, so it'll give me these three contracts to look at, and this calculator.sol file. And I'm just going to copy this and paste it here. And you can see when I save it here, I get this error and it's saying it requires a different compiler version. So on the blockchain, it's very important to define the version that you wrote this code in. So I need it to be compiled in this exact version. Otherwise, there could be incorrect code or a security risk or something like that. So I'm going to change the compiler version in a second. I'm just going to give you a rundown of the code. And like I said, if you know Python or JavaScript, you should be able to read this. A contract is kind of like a class. I can declare variables. This is a constructor. And then I have a couple different functions. These modifiers, if it's public, it means that anyone can call this function. Basically, anyway, it's public if it's deployed on the blockchain, so anyone can see it. By using this public keyword means it's callable. So an external party can call this function. View means it's not updating anything on the blockchain. I'm just returning something that's already stored on the blockchain. And then peer is similar to view in that I'm not storing anything on the blockchain. This is the only function that's actually updating anything on the blockchain. So this is actually the only function that costs gas in this whole operation. So I'm going to look at, first compiling this contract. If I try to compile it, I should get an error. Oh no, actually when I hit compile, it automatically changed my compiler version to what I set up here. So now there's no more error. And it should automatically set these options, so I don't have to change anything. And it compiled. Now at the bottom, when I compile it, I have two things. So I can get the bytecode, which is what gets deployed to the blockchain. You can see all the opcodes here. There's actually, you can use these to optimize your code on the blockchain. And there's a nice GUI that I don't know if we'll have time to look at, but maybe I can show you later, or you can look at the Brownie Gui, and that helps with that. And then there's the ABI, which is the application blockchain interface. And this can get really, really long, but this basically tells you and your programs how you can interact with this smart contract. Yeah, just like an interface. So those are the two things that you would need if you were to deploy a contract to the blockchain. And because it gets compiled down to bytecode and then deployed. So I can choose my environment. This is kind of like an online, or Remix gives you kind of an online version of Ganache. You can see all these accounts pre-populated with 100 in this JavaScript virtual machine. Now I am going to use injected Web3. So injected Web3 basically takes accounts, and I mentioned MetaMask earlier. Don't worry, this is not my real Ethereum wallet, but yeah, I mentioned MetaMask earlier because this is the most popular wallet for interacting with blockchain or websites and apps that use blockchain, that need a blockchain account connected. You can use this browser plugin MetaMask, and MetaMask can manage all of your accounts. You can either use MetaMask to create accounts or import accounts that you have from other places. Like here, I am importing accounts from Ganache. Actually, I need to delete these and re-import because I restarted my Ganache, so it regenerated new accounts. And then here you can see all of the networks that I can connect to. I have the Ganache network here, which is connected to a local host. My local host 7545. I also have the Ethereum mainnet. And then I have all of these test networks. So some of them use different algorithms. Some of them are proof of authority. I think Robston is proof of work. So it's a test mining network. And then Rinkeby is the only one that I have test Ethereum on right now. So I'm going to go to my account on Rinkeby, just the first account. Now I got this test Ethereum from something called a faucet. And if you're interested, I did link, because sometimes the faucets update, a lot of them don't seem to be working right now. So I did link a faucet that is actually working if you want to get test Ether for Rinkeby, and they have a couple other options. But you can go to this website, faucets.chain.link. Chainlink is a blockchain related solution that you can look at. But anyway, you can get some Rinkeby there pretty easily. Yeah. So where? Oh yeah, I was in Remix. Okay, so now I have this account, my first account, and that should be connected. Yeah, this is the same account that's showing up in Remix. So injected Web3, because I almost called this Firefox because of the fox. MetaMask is injecting a Web3 provider where I can access it in this website. So that any website that connects to Web3, MetaMask will pop up and ask, hey, do you want to connect your wallet to this website? So that's what I did already. And I can deploy this contract because I have some gas in my wallet. And MetaMask is going to ask, is that okay? I'm going to confirm. And it deployed. So if I come down here to the bottom, I can see that I can see all my functions that I can interact with. Now I should have, yeah, in the logs down here, I don't know if I can move this. Yeah, in the logs down here, it says view on Etherscan. So if I go to that website, this is a test network. So rinkeby.etherscan.io. And there's a main Etherscan for the mainnet. But this basically lets me see, I can traverse through any transactions because of course I can see anything that's ever happened in the history of the Ethereum blockchain. So I can traverse through the whole history of transactions on this site. And for contract deployment, I'm still deploying. Yeah, you can say two, you can see that the two field was empty. So it's considered a contract creation or contract deployment. It came from my address. It has all the other information. It says it's still being mined. Oh no, it is deployed now. So I have to zoom out to get the options. Oh yeah, there we go. Okay, and I can see information and I can actually look on here and see contract code for contracts that have been deployed in the past as well. So I'm going to go back here and oh yeah, and you can see in my account, you know, it updated, it took some test Ether out of my account. So I can interact with the blockchain if I want here. I can call functions. Like I can call my setnum function, which is going to take some gas. And you can see that it's highlighted in orange, just to denote that it does take gas to run this function. So MetaMask will ask to confirm the transaction. And it confirmed it. And now I've set this number, oops, So now the number on the contract is equal to 5. So if I get the number, which actually since I set the number itself as public, and I also made a getter function too, I can actually get the number either way. So I really wouldn't need that function, but I can get the number, and it returned 5 here. Yeah, and then I can interact with any of these other contracts. So I'm going to go back to the local environment here. And try to compile a contract and deploy it in the same way with Web3. And you can see whatever network I'm deploying to, a testnet or mainnet or to a local network, it's the same APIs that I'm going to use. So I'm going to go to, yeah, my local environment. And here. Step 2. No, step 3. Okay. So from Web3, import Web3, and then, oh yeah, I need my compiler. So since I'm dealing with Solidity files, and by the way, the Solidity plugin, you can get a Solidity extension. It's just the first one, the most popular one that gives you, you know, autocomplete and highlighting and all those things. So from C import, and this is the library that I installed earlier. So this is this library for compiling Solidity. So I'm going to install 2 things. So compile source and install Sol-C. Okay. And I'm going to copy over what I have here. So I'm using the same, basically I'm still connecting to my Ganache, and I'm yeah, connecting to the same provider. So all of that is the same. And then I'm going to, instead of creating a transaction, I'm actually going to open my contract and compile it. So let me, actually I'm running a different file now. So I made a compile local file. Okay, that's running. And now I need to import one of these contracts. So I think the only one I'm going to have time to do is calculator. So I'm going to do with open. So I'm just going to open that file. So contracts and then slash calculator.sol. And this is just regular Python. So I need to read that file. So I'm going to say contract equals f.read. And now I have the contract here. So I can print that out. And if I do, you can see it's just exactly the code from that file written out. Okay, so I have the contract now, and I need to compile the contract, but it's going to give me an error if I try to compile it because I need the version of the Solidity compiler that this requires. So I need to install version 0.6.0 first. So to do that, I can use that install function that I imported. And I can do 0.6.0. Yeah, and then I can do compiled just I'll call it compiled sol. And then here I need to, there's a couple different compile functions you can use. You can look at the sol cx library, and there's a couple different ones, but I just use compile source for this. And then it takes a couple different things. So I need my contract, which is the uncompiled contract. And then I need to tell it what values I want. So I need to say what values I want to output. And just like on the web, you know, it gave me the ABI and also the bytecode. So that's the same thing that I want right now. And then I can get the compiled contract. So I've compiled source, and I need to get, I can get the contract ID if I want, and then I can get the contract interface, which will be compiled sol, because I already have it here. And then I can just do pop item, and then this. Yeah, and that should give me that. I have the compiled contract, and I'm just going to save the bytecode for easy reference. So bytecode equals contract interface, and then let's say bin, and then ABI and contract interface, and go to ABI. Okay, and now I should have this. I can print this out, the bytecode and the ABI, and that should be working. It's taking a minute to compile. Oh, it says it got an unexpected argument. Let's see, got an unexpected argument of output. I wonder if I used the right. Oh yeah, the API I was supposed to use is output values that I want. Let's see. Okay, yeah, so that is kind of the jarble, the bytecode and the ABI. Okay, so now I can use these to actually deploy the application. So I'm going to set a deployment account. So if I'm just going to copy this line actually. So this w3.eth API lets me set a default account, and then it will just use that account for deployments. And since I'm already connected to the Ganache blockchain, it will just take the, I can just use that first account from there. So to deploy, I'm going to use the contract API. So I'm going to just say calculator equals w3.eth.contract. And then I need to set the ABI and the bytecode. It's bytecode. And I think that's the only thing I have to set. Let's see if that works. Okay. Well, it didn't break or error. That's good. And then I can actually, I have to make a transaction to actually deploy this to the blockchain. So I'm going to, make a transaction. That will equal w3 .ether, and then I'm going to use this API. There's a couple different ones, but I'm going to wait for the transaction receipt. And then let's see, calculator. Oh, I think I missed something here. I forgot the actual transaction. So I've created the contract here as calculator, and then I'm ready to deploy it, but I haven't deployed it yet. I need to actually create the transaction. Yeah, so that should create the transaction, and then I can wait for the receipt, and then I can just send out the receipt. Okay. While local. Okay, so this is the receipt. It's kind of hard to read. I can also see it over in my Ganache. So you can see this is of type content. This transaction is of type contract creation. I'm sorry. Yeah. And so if I click on this, I can see here is the data that I sent over, the bytecode. And then I can see the address of the contract where it lives now. I didn't send any value because I was just sending the data and how much gas it costs and all that. So if I go to, by the way, it doesn't look like it costs gas because this, it just rounds here. I don't know if there's an option you can turn that off, but it rounds to 2 decimals. But actually this, I have like 89.99 something Ether there. Anyway, so that's my transaction that I created. So I can interact with that here now too. So if I, let's see, I'm going to use the API. So now I have to reference, so if I want to interact with the contract, once I've deployed it, I have to reference the address of that contract. Like I can't just interact with it with the contract I made locally. So I'm going to reference the address where it lives on the blockchain now. So I'm going to say calculator equals w3.eth.contract. And then I'm going to tell it where the address of the contract is. And that's going to, I'm going to get the address back in this transaction receipt. So if I do transaction receipt dot contract address, and then I can do ABI equals ABI. So the ABI, I need the ABI because that's going to tell, it's going to tell my program like how I can interact with that contract. And then this is going to point to where the contract lives, so I can actually call the live contract. So now I can call functions on the contract. So if I look at functions, I can call, let's say, the getNum function or whatever. I can say, print calculator. So I have a reference to the contract. I can say functions dot get num, and then I can use dot call. So dot call is doesn't cost any, or the get num function doesn't cost any gas because I'm just reading something from the blockchain. I'm not writing anything. So I can use dot call instead of transact here. So I'm going to do that. And yeah, so basically I just read from the blockchain, and that shouldn't create a transaction either. Yeah, you can see there's no new transactions here because I was just reading information. So there's no transaction needed for reading from the blockchain. So I'm going to, yeah, let me transact. So I have some other functions like I have, well, this is the only one that will need a transaction. So I have set num. So let me call set num from here. And let me call print. I can do calculator dot functions dot set and I should be able to just pass in a number. So I'm going to pass in 7, and then I'm going to do transact this time. And that should run a transaction. Let's see. Okay, cool. And that just prints out the bytecode. Yeah, I don't really need to print that out. But you can see that I've just kept creating the same transaction for some reason. But this is the one that I just ran. It created that transaction. And then you can see that this was a contract call, which used some gas because I was setting information on the blockchain. So it's not really helpful to print this value out, I guess. So I don't really need to print that, but I should now print this get num again, the getter, because that will show what the value is and how it changed. So I can do that. And yeah, so you can see the value is 1, and then I set the number and the value is 7. So that's basically how to interact with a contract. If I had a remote contract, I don't know if I have it linked here. Yeah, if I had a remote contract, then I could go into something like Etherscan, and oh, I have one here. And I can grab the address and the ABI for that contract, and then I can interact with it in the same way. So I'm just pasting a link that I have here, or I can paste it in the chat too. I think I just always use CryptoKitties because this was like the one big, I guess, smart, not smart contract because it's a group of smart contracts, but this is the one big company doing this back when I started learning about blockchain development. I think they started maybe like 2017. So it gives me all of the information. This is the main Etherscan. It's not on a testnet. This is their deployed contract. Oh yeah, and you can see they deployed it back on 2017. And this has all the contracts. Basically, it's a whole bunch of contracts that are deployed. There's one, something like a kitty main contract, and then all of the other contracts kind of branch off of that or do different functions with the kitties. Anyway, you can see here that Etherscan gives me the code for the contract. It also gives me the ABI, and then I have the contract address up here. So I can actually find any contract, search for it on the blockchain, and then I have the address, and Etherscan will give me the ABI, and then I can use that in my programs. Here I already downloaded the ABI for CryptoKitties to play around with. And you can actually see that it's 1100 lines long of ABI. So those can get quite long depending on what you're doing in your functions. I think that was it for Web3. So one more popular way to interact with blockchain is through services. There's a whole bunch of services that will run nodes for you, and that's probably how you would interact with live contracts, or how most people do it. The service that I use right now is Alchemy, so alchemy.com, but there's a bunch of them. There's one that begins with an M that I was trying out the other day, and yeah, I don't have a preference really, but this is just one of them, and it gives you a free development tier if you want to interact with live blockchains. Yeah, and their API is really good. So I think that's it for talking about Web3. I had another section talking about Brownie, which is, I mean, Web3 by itself is really nice for testing things out, but you can already see we're hitting its limit as far as like we have to rerun the deployment and everything every time we want to interact with the contract or do something else. So there's another tool called Brownie. That's a framework that heavily relies on this Web3.Pi library, which is what you'd probably be using if you're going to do Python development with the Ethereum blockchain. Now, these libraries are for Ethereum, but they also work with interchain protocols that work with Ethereum. So there are projects now that are trying to tie together all these different blockchains, like, for example, make Bitcoin be able to talk to Ethereum, because right now they're completely separate blockchains. So they have this group of projects like Cosmos and Polkadot called interchain protocols, and they try to tie together all these different different blockchains so that you can transfer value. And if you transact on one blockchain, you know, you can transact to another blockchain and stuff like that. So those projects, you would be able to work with those projects using Web3 Pi and Brownie. I know you can do it with Polkadot so far and maybe other projects. Are there any questions about this?
There are no questions right now.
Okay. Yeah, I had a couple more compiled contracts, but yeah, maybe we could just install Brownie. I was actually going to push this code if anyone wants to see it or interact with it. So I made this empty repo so far, and I'm just going to push it real quick. Git status. Oh yeah, the Git repo yet. Do git remote add origin and git yeah, that's fine. Git add and then git push issue origin. Okay, so if you want to go to this website, you can see the playground for that. Maybe I'll add the rest of my code and clean that up a little bit if you want to check that out later. And it has some of the contracts that I've written before if you want to take a look at that. So I guess I have like maybe 10 minutes. So I want to, oh, why is my MetaMask open? Oh, I think I just ignored a transaction before. So I want to go into a different folder. So I think I'm going to I'm just making a new directory now, so. Okay. And okay, so I have an empty directory and I'm going to initialize Brownie inside of here. So to use Brownie, I might have this. No, I don't think I actually have it in my links, but you can just look in the quick start and oh, I think maybe it's an overview. Well, I guess it doesn't really say here, but you have to install Brownie F. Yeah, I don't know where it is in the documentation. Anyway, I'm going to create a virtual environment real quick so I can install Brownie. And then I'm going to, actually the documentation will recommend that you use pipx. I think it's called pipx. Oh yeah, here's installing Brownie. Yeah, it will recommend that you use pipx. You can if you want to, and I think that's just so you can not have to install Brownie inside every single folder where you want it. But I'm not going to use that right now. So I created a virtual environment. I'm going to go into my virtual environment and I'm going to install Brownie. So first, I think I'm just so used to using poetry that I'm going to do poetry init. And create a PyProject.toml file. And I can do poetry add, let me see. Oh, I think it's Brownie. Oh, it's Brownie. Yeah. I should copy instead of typing out packages. Okay, so that has to install. And once that installs, I'll be able to initialize a new project. And so Brownie gives me a lot of features for developing these applications. You can see in the docs, there's a ton of different things. It has its own package manager. There's a GUI where you can view reports from plugins and code coverage and things like that. There's a console. It has good debugging features. It uses, or you can use PyTest. And there are a lot of tests that you can run with Brownie for that. Or it has a built-in way of running PyTest tests. Yeah, so I'm gonna actually, I think in my outline, I'm gonna do, okay, so I'm gonna create a new Brownie project. So I have to create a new Brownie project and the command is Brownie init, but I think it's gonna fail because I have a virtual environment in here. Oh, did I not install? Oh, it didn't install. My Python requirement, it's a little hard to see. Requires Python. Oh, right. So it requires Python. And I might have, 1 second, let me check my Python version. So I do have the correct Python. Let me see. I did. So I think actually it'll give me the solution maybe. No. Oh yeah, because it requires Python. So I think I can just copy this then, maybe, into my Python version. Oh wait, I thought it auto copies, but it doesn't in the VS Code terminal. Right. Okay, let's see if that works. Oh, wait, I have to poetry. Okay, that's working. Good. All right. There are a couple other dependencies, so I might as well. Oh, that finished quick. Okay, so there's another dependency that you'll have to use with Brownie, and that's Ganache Cli. So this is the GUI version of Ganache, which is really great for just quickly viewing things. But there's a really powerful CLI that they have, but it's JavaScript based, so you need to install it with JavaScript. So I already have it installed globally. You can choose to install it globally or not, but you can basically do this, install npm install Ganache CLI. I will say that it seems to be a little bit picky sometimes with the node versions. So I had to use it with node 16. It wouldn't work with node 17. I think if I check my node version now, I'm on 14, so that should work. But yeah, I can run Ganache CLI from a terminal. And if you look at what Ganache CLI does, is it gives me all of these accounts, all of the information, private keys, and then it runs its server, and the regular Ganache runs on 7545, and this one runs on 8545, so they won't conflict. Now I think I can just open another terminal. Yeah. To use the Brownie testing. Oh yeah, but I will have to get in my virtual environment here too. Okay, so now I have Brownie, and I should be able to oh, it didn't. I thought I just installed Brownie. I guess I would have a package lock if I did. So let me try again. Oh yeah, it's still complaining about the dependencies. All right, so I did have this working before, but okay, let me try that. Okay, that actually worked really this time. And sometimes it takes a while because there's a lot of different tools that it uses. Yeah, to install and stuff. Okay, that should be done. Okay, so now that I actually have Brownie installed, let me try one more time. Okay, yeah, I thought so. It failed because the directory is not empty. So basically, I have to create a new directory. I called the outer directory Brownie test. So I guess I'll call this one Brownie project. Okay, cd Brownie project, and now I'll be able to do Brownie in it. So it's a framework, and it gives me all of these different things out of the box. So just to run down these really quick, build, I shouldn't have to touch this. This just builds contracts and interfaces and whatever I need. Contracts, this is where I'll put my actual contracts. And then I can, if I have interfaces, this will go there. Reports are also generated. And that's what I'll use in the GUI. And then I write my own scripts. Like if I want to deploy a contract, I can write a script for it. Or if I want to interact with contracts, you know, a lot of times you might have a lot of scripts here doing different things. And then tests are written with PyTest. So I only have a few minutes. So one thing that is great about getting started with Brownie, I think this will be the best thing to show in the next 5 minutes, is that if I go to Brownie, it keeps in the theme of brownies. So they have these things called Brownie Mixes. So if I go to GitHub, I can see all of these predefined Brownie mixes. Yeah, so if I want a front end for it, or I want to build a decentralized organization on the blockchain, it has all of these starter mixes. And one of the nice things about these starter mixes is that they come with testing and some scripts and stuff that you can just already take a look at. So if I go to Brownie, let's see. Actually, I'm in Brownie project. Let me get out of Brownie project. And if you look at the docs, I can just use I think it's in quick start. Yeah, Brownie Bake, that was it. So I'm just going to use their token contract. So that's the easiest one. Okay, so one thing about that is that when I Brownie Bake, if I use the Brownie Bake API, it creates a folder with all of the subfolders. So I get, you know, I get whatever contracts. So I get a token contract for, I think this is this an ERC20? Yeah, it's an ERC20 token. And it gives me all of the functions and stuff. And then I get, let's see, scripts. So I get a deployment script for the token. So Brownie automatically handles compiling tokens, and it's using, you know, things like the Solidity compiler and Web3 Pi and all that stuff under the hood. So it'll automatically compile tokens, and then I can just import them directly from Brownie. So any tokens that are in here, like I have a token, I can import that from Brownie. I also get access to accounts. By default, accounts means these accounts with the Ganache CLI. That's what it connects to by default. But you can set your network and accounts as whatever things that you want.
Coming up on your 5 minutes now.
Okay, thank you. All right. So yeah, I don't really have time to go too much into Brownie. A couple of interesting things are, so let me go into the token one real quick. Well, first I can do the Brownie console. So if I go into the Brownie console, it's kind of like if you've used the Django shell, it gives me features to interact with my Brownie environment. You can see it's listening the RPC client that I'm running over here. And I can do something like oh wait, I can do, it does have autocomplete, so network, and then, oh, it's not liking that for some reason. I guess I can't do that one on the console, but okay. So anyway, there are a lot of different things, like I could check out accounts. Yeah, I have access to that in the console. So I can see all my accounts and use the Brownie API from there. So And then another thing is I have the Brownie testing. So if I run Brownie test, that will run any tests that are in this folder prefixed in, I think they have to be in the test folder and prefixed with test, but I can run, it runs all those tests with PyTest. And yeah, there's several tests. It shows me passing, it'll show me failing. That's just the standard PyTest pass fail. And then if you want to, you can do coverage report too, and it has some built-in features like that. And then the coverage report, you'll be able to see that in the GUI. All right, so I think that's the only thing that I have time to show right now. I did make a blog post a few months ago with blockchain resources. I have a few more things I want to add that I'm going to update that post and post again later today and tweet that out. So like I said at the beginning, this is my first Python talk, so I'd appreciate if you have any feedback for me. You can DM me on Slack or reach out to me on social media. And I just want to say that I attended this conference last year and I didn't see really anyone talking about blockchain. And I think that that discussion really belongs in the Python community because Python really has great tools for developing with blockchain. And I didn't even know about those before when I was working on blockchain projects. I just thought everybody uses Truffle or something like that, which is JavaScript based. But the Python tools are, you know, at least as powerful as anything else out there, at least for Ethereum. So yeah, thank you for attending my talk. And let me know if you want to continue talking about blockchain. I think we're going to go into a room right now, or like a private room. So if you want to hang out and talk more face to face, so I can actually see you, that would be cool too. So yeah.